Good morning, Monadal. Today I am hereby to give a presentation on strengthening structural materials through computer modeling. Mm. Before getting into topic, I would like to give a small introduction of myself. My name is Jisana Reddy, having a PIN number of 21955A2109. Mm. Okay, now let's get into topic. Mm. Before getting into topic, I would like to give a small overview of what I would like to express or what I would like to teach in this presentation. So in this presentation we will come across introduction of my topic, and next microstructure modeling, next deformation mechanism, next validation and verification, and then application, and further we will also discuss about the future directions. Mm. So without getting into delay, let's get into topic. Mm. So so now now I would like to give a small I would like to give an introduction on this topic. Mm. Uh, I am here. My topic is nothing but I would like to increase the properties of the material by using computer modeling, in which I will take a case, and I would like to further apply any properties to it, and then in all, and then instead of doing a practical a practical, what would like to say, instead of doing a practical work on the workpiece, I was supposed to do the task performance total in computer modeling, and and the results may be positive or negative. I would like to follow it. For now, let's get into microstructure modeling. The microstructure model of a material refers to its internal structure at a microscopic level. Computer modeling can simulate the arrangement of atoms, grains, and other features, then affect the material properties. One approach is to use finite element analysis to model the deformation of a representative volume element, which is also known as RVE of the material. This involves dividing the RVE into small elements and solving solutions for each element to determine the overall behavior. So in this figure example, I am I placed the image. So if you observe the image carefully, it describes about the microstructure of a item of a particular particular. Hmm. Next, deformation mechanism. As you know, as when we apply a force, any type of force on a substance or on any object, then as a result it will supposed to deform. So now deformation is common in everywhere. Deformation is exist in anywhere at, so at which when we apply a load, in other words we can able to define as the place at which we apply the force, apply the load. As a result we can able to come across a deformation. Next, when a material is subjected to external force, it undergoes deformation. Next, computer modeling can stimulate the different deformation mechanism that occurs in structural materials, such as dislocation motion and crack propagation. Next, by understanding this mechanism, researchers can develop strategies to prevent or mitigate damage in the material. For example, adding alloy elements or changing the process condition can alter the microstructure and improve the resistance to deformation. Next, validation and verification. As you know that we are supposed to do the computer modeling, and next we would will the results obtained from it is supposed to be validated. We can't trust blindly about the computer modeling. The computer modeling may give correct or incorrect results, but we supposed to validate the results, or once we need to verify and recheck and reclaim the results which we obtain to so To ensure the accuracy of computer modeling results, it is important to validate and verify the models against experimental data. So, these involves comparing the predicted behavior with actual measurements under controlled conditions. Next, if the model agrees well with the experimental data, it can be used to make prediction for other scenarios and materials also. And however, if there are discrepancy, adjustment may needed to be made to the model or to the experimental setup. Next, application of this. Computer modeling of structure and material has numerous application in industry and academia. For example, hmm, if we, it can be used to design new material with improved properties and optimize process, optimize processing conditions for existing materials, or we can able to predict the lifeline of a component under various loading conditions. In addition, computer modeling can provide insights into fundamental aspects of material science, such as the relationship between microstructure and mechanical behavior. Future direction. Future direction. As computing power and simulation techniques continue to advance, the the possibility for computer modeling of structure and material are expanding. One promising area is the integration of machine learning algorithm to improve the accuracy and efficiency of simulation. In addition, multi-scale modeling approaches that combine different levels of details from atomics to microscope scales could provide a more comprehensive understanding of material behavior. So by this we can able to understand that by this computer modeling we can able to analyze multiple functions. We can able to analyze and stimulate the data what we require. We can apply the load at a specific place at which we would like to test the material, and then while we applying the force we can able to extract the displacement caused by the load at the location, or we can able to understand what the process is going on when the loads are supposed to act on the object or at that location. Mm. So it is required to learn the computer modeling in order to save the time and money. Thank you Ananda. I would like to thanks for your interview. Okay, thank you.